Okay, in this video, we're going to look at the hyperbola. So the hyperbola is the locus of a point which moves in a plane such that the absolute value of the difference of its distances from 2 points in the plane is constant. You're going to notice that this definition is a bit similar to the one for the ellipse, except that for the ellipse here it was the sum. So you're going to find that there are quite a few parallels between the ellipse and the hyperbola. So let's see how the hyperbola is going to look like. So just like in the case of the ellipse, hyperbola is going to have a center, and then it's going to have two vertices again. So going to be a vertex somewhere here and another vertex there. Then the graph is going to be shaped something like that. It's going to have two branches. Okay, so the distance from the center to each of the vertices is a, as it was before. So that is going to be a0. This is going to be the other vertex, negative a0. The foci, there'll be two of them again, one here and one there. So they will again be a distance c from the center. So the other one this side. So the horizontal axis here, in the case of a hyperbola like this axis here, is going to be called the transverse axis. So this is the transverse axis here, and then there's going to be an axis through the center perpendicular to the transverse axis. The length from here to there is going to be b, just like in the case of the ellipse. This one is called the conjugate axis. Okay, so it was a minor axis for the ellipse. Then in this case, the numbers a, b, and c still satisfy the Pythagorean relationship, except that this time it's going to be a squared plus b squared is equal to c squared. Notice that this time the distance from the center to the focus is bigger than the distance from the center to the vertex, and then there is nothing that's going to restrict a to be smaller or bigger than b. All we can say is that c is going to be bigger than both a and b. And then something that we didn't have for the ellipse is asymptotes. The hyperbola is going to have a pair of asymptotes that go through the center. So the asymptotes are lines that the curve gets closer and closer to but never touches, and the curve does not cut across the asymptotes. the equations of the asymptotes for this orientation will be y equal plus or minus b over a times x. So that's going to be the asymptotes, and then we are going to have directrices, but they will be closer to the center than the vertices, and the directrices again will be distances a squared over c from the center. So for a hyperbola like this one, so if this is the x-axis and that is the y-axis, so this is centered at the origin. So it's centered at the origin. The transverse axis is along the x-axis. Then its equation is going to be x squared over a squared minus y squared over b squared equal to 1. So notice the difference here with from the case of the ellipse is in the case of the ellipse this was plus, this time it's negative. Since there are no restrictions on whether a is bigger or smaller than b, here a squared is always the number dividing the positive term. So a squared always divide the positive term. So we'll see how this works out in through examples. Now you can see that here out of the two axes, the transverse axis, the hyperbola intersects twice, and the conjugate axis, it never touches. So you can confirm this like through setting either x or y equal to 0 in this case. Set y equals to 0, this thing's going to give us x squared is a squared, so x is plus or minus a, which gives us these two points of intersection. And then if we set x to be 0, this thing is going to give us y squared is negative b squared, but then we cannot have y squared being a negative number, so that means there is no y-intercept, which is the case of the hyperbola we have. Right, what I want to do next is we're going to translate the center from 0, 0 to hk, and then rewrite this equation accordingly. Okay, so if the hyperbola is now centered at hk, right, so then this equation here is going to be x minus h all squared divided by a squared. Take away y minus k all over b squared. So for every y we replace by y minus k. For every x we replace by x minus h. The asymptotes will have the equations y minus k equal plus or minus, we are going to run out of space here, so y minus k plus or minus b over a x minus h for the case of these asymptotes here. So, and then otherwise so that's basically what happens. The hyperbola is also going to have eccentricity just like we saw for the ellipse. So the eccentricity A is still going to be exactly the same as was defined for the ellipse. So it was C over A. It is still going to be C over A. However, notice this time, because C is bigger than A, so the value of the eccentricity for the hyperbola is going to be bigger than 1. Okay, so that's the hyperbola for the case where the transverse axis is horizontal. Transverse axis is vertical, so I'm just going to take the case where the hyperbola is centered away from the origin at HK. So if this is the center and our hyperbola this time is looking like this, right? So the asymptotes are going to go something like that. So what's going to happen in this equation here, the x and the y terms are going to trade places. So this one is going to be y minus k squared over a squared x minus h squared over b squared. Notice the a squared, like we said, is always dividing the positive term. So that's the case where the center is at HK. Okay, so that's about it in terms of the theory. We are now going to look at some examples. Alright, in this example we are given an equation of a hyperbola. We will want to find the coordinates of the center, vertices, and the foci. We will want to find the equations of the asymptotes, and then the eccentricity. We will make a sketch. So let's start with A. Go to x squared over 16 divided by y squared over 4. Minus y squared over 4 is equals to 1. So here A is going to be square root of 16. We said A is always the one that's dividing the positive term. Then C, remember that A squared plus B squared is C squared in this case. So C is going to be the square root of 16 plus 4, going to be the square root of 20. That is going to be 2 square root 5. So once we have got C, then we can find the eccentricity. So remember, the eccentricity is always C over A. So this is going to be 2 square root 5 divided by 4. It's going to be square root 5 over 2. Now, when it comes to the sketch, so let's do the sketch now. Since the equation is like this, the center is going to be the origin, because we just have the x squared and the y squared term. So we have got an equation of this form here, right? So the center is going to be the origin. Now we need to decide on whether the transverse axis is horizontal or vertical. Well, from this it's going to be horizontal, but just in case we were not sure, we can test this by doing the x and the y intercepts of this equation. The x-intercepts, for instance, if you set y equal to 0 here, then you're going to get x squared over 16 is 1, so x squared is 16, so x is plus minus 4. So that means this graph is going to cut the horizontal axis at 4, 0 and minus 4, 0. Now, but if you do the same thing with the x, if you set x equals to 0 here, then all of a sudden we're going to have y squared is negative 4. But then y squared is negative 4 is not possible, so that means this graph is not going to cut through the vertical axis. So this is telling us that the transverse axis is going to be horizontal, okay? But you know, just for the sake of progress, well, if the x term is positive, then the transverse axis is horizontal, right? So there's going to be asymptotes here. Let's see. So let's find the coordinates of the center. Is going to be 0, 0. The vertices, we're going to have one vertex there. A is 4, so one vertex at 4, 0, another vertex at minus 4, 0. Then the foci, one focus at 2 root 5, 0. The other one at minus 2 root 5, 0. So we've got the coordinates of the center, vertices, and foci. Then we need to find the equations of the asymptotes. The equations of the asymptotes are given by this equation here. So we're going to have y equals to plus or minus, b is 2, a is 4, so that's going to be 1/2 x. Those are going to be the two equations of the asymptotes. We did not talk about the equations of the asymptotes for the case where the transverse axis is vertical. So what's going to happen there, the x and the y terms are just going to swap positions. So for this one, it's going to be x minus h is equals to plus or minus b over a, then y minus k. There will be the equations of the asymptotes. Alright, so that sorts out a. Well, let's just make sure we have got everything. We did the eccentricity, we did the asymptotes, we have got the sketch, so we can go to b. So in part b, we have got 25y squared minus 9x squared is 225. To cast this in standard form, we're going to divide both sides by 225. So this is going to be y squared over 9, I believe, and this is going to be x squared over 25. This is assuming that 9 times 25 is 225. Let's confirm this. 9 times 25 is indeed 225. Then this is going to be equal to 1. From this, the a, we said, is always the one that's dividing the positive term, means A is going to be 3, B is going to be 5. So notice that A is bigger than B, but there's nothing that says that this cannot happen in the case of a hyperbola. Then we can find C. C is going to be the square root of the sum of the two of them. 9 plus 25. 9 plus 25 is 34. So that is going to be C. So the eccentricity is what is the eccentricity? C over A. So C over A, so it's going to be square root 34 divided by 3. Now for the sketch, since the positive term is the y term and the transverse axis this time is going to be vertical, so our graph is going to look something like this. Center is 0, 0. One vertex is going to be at -3, 0, -3. The other vertex 0, 3. One focus at 0, square root 34. The other focus at 0, negative square root 34. Then the equations of the asymptotes will be x plus or minus b over a. B is 5, a is 3. So 5 over 3 times y. So we've got the coordinates of the center, 0, 0. The vertices, the foci. We have got the equations of the asymptotes. We have got the sketch. So B is sorted. We're now going to go to C. In C we've got 9x squared minus 4y squared minus 36x plus 32y plus 8 equal to 0. This time we're going to have to complete the square first. So we group the x terms and we also group the y terms. So we're going to have 4y squared here minus 32y, negative 8 this side. Then we can factorize 9 here. It's going to be x squared minus 4x. Can factorize 4 here. Y squared minus 8y. Then we complete the square. It's going to be x minus 2 all squared. So ordinarily we're going to add 4 this side, but it should be 4 times 9. So it's going to be 36. And then here it's going to be y minus 4 all squared. This time we are not going to add, we're going to subtract. We're going to subtract 16. We have to subtract 16 times 4 because of this 4 here. So this thing is going to be 9 into x minus 2 squared minus 4 into y minus 4 squared equal to, on the left hand side we have got 36 minus 8 minus 64, which is minus 36. So what it means is we're going to have to divide by negative 36 on both sides. So this side becomes 1. This term becomes a positive. So y minus 4 all squared divided by 9. And then this one becomes negative x minus 2 all squared all divided by 4. So what this is telling us is that a is 3, b is 2, and c is going to be the square root of 9 plus 4. It's going to be square root 13. So the eccentricity is going to be square root 13 over 3. We need to make the sketch. From this again, the center is going to be at 2, 4. And since it's the y squared that's positive, the transverse axis is going to be vertical. So at 2, 4, the transverse axis is vertical. So something like this. So our graph is going to look something like that. Oh, okay, well, let's just wait to see where the vertices are. So center is at 2, 4. Then from the center to each of the vertices, the distance is 3. So that means this one is going to be 2, 7. This one indeed will be in the first quadrant, 2, 1. And then the focus, the one here, will be 2, 4 plus square root 13. The other one somewhere there is going to be 2, 4 minus square root 13. All we are left to do are the asymptotes now. The asymptotes will be given by x minus h equal to plus or minus b over a y minus k. So h is 2, b and a, b is 2, the other one is 3. So 2/3 here, and then y minus 4. We're just going to leave it in this form. So those will be the two asymptotes. We've got the sketch, we've got the eccentricity, we've got the asymptotes, coordinates of the center, vertices, and foci. Alright, we're gonna give you a chance to have a go at the last one. This question D. So just have a go at this, and then once you've done, so while you have a go at this, while you press the pause button, then when you press play, you can compare with our answer. Alright, so we hopeful that you've done D. I'm now going to scroll down to our solution for D. Okay, so we're going to start by grouping the terms. So the y terms together, the x terms together, the constant to the left hand side. Then we factorize, then we complete the square, then we divide by 36. So from here it tells us that a is 2, b is 3, c is the square root of 9 plus 4, and the eccentricity is square root 13 over 2. So from this, the center is going to be at 2, -3. Because the y term is positive, the vertical, the transverse axis is going to be vertical, and so your vertices will be at 2, -5, 2, -1. The foci will be 2, -3, -13, 2, -3 plus √13, and these will be the two equations of the two asymptotes.